Mr. Corey Harris Jr. is back again with us, solutions architect with AWS. Corey has been generous enough to do several really nice hands-on presentations for us, really centering around data lakes. He started off with a strategy conversation with us back in spring, generally talking about sort of introduction to data lake concepts in AWS and outlining strategies to bring your organizations in that direction. Followed that up later in the summer with a more detailed hands-on implementation and demonstration of QuickSight and some other tools in AWS. And he's going to continue that concept and that demonstration today, introducing us to some AI and machine learning tool sets, building on that data lake concept. So with that, I will hand it over. Thank you all for joining. Hope you enjoy the show.
Great. So I want to thank you all for allowing me to come again today. Definitely have, a lot of fun talking, and not just talking, but showing the power of the AWS platform. So what I'm going to do is I'll give a brief intro, and then I'll give some context to those who may not have been aware of the previous work we've done and sort of bring it full circle. So I'm Corey Harris. I work with AWS. I'm a solutions architect. I'm what we call a generalist. So technically, I don't have a particular specialty, internally to AWS, right? I cover the broad spectrum of tools. However, my specialty is serverless. So I am a part of the serverless technical field community. So from a web development standpoint, customers trying to look to adopt serverless technologies. I heard a conversation about API gateway refactoring or Cognito. So that's right up my wheelhouse, right? I was a previous web developer, service developer, for about 4 years before coming to AWS, and participated in a lot of hackathons and kind of built this knowledge set of how to effectively build software and infrastructure in the cloud. And also, I'll drop my LinkedIn in the chat as well if anyone wants to keep in touch. Maybe you want some technical guidance. If anyone's looking to get certified, feel free to reach out as well. Currently, I have 8 of the 12, so I can definitely give some insight into just how to approach being certified, or the value you get out of being certified, and just things of that nature. So let me share my screen and just give some context to the previous discussions, and then we'll dive into what we have for today. So just give me a second. Okay, so here's what we did before. So again, I won't go into too much detail just for the sake of time, but a data lake at a high level is really the ability to land uncurated data. So you want to be able to have a place where you can persist raw data with the notion that later you're going to need to do something with it, right? And typically this is overlooked because a lot of customers may not be used to this concept. It is a modern concept, but it's valuable because enterprises collect a vast amount of data, right? You have ERP systems, you have applications that omit artifacts such as clickstream data, impressions on a UI to correlate click streams to recommendations that you can give customers to understand the customer journey. And you need a place to store this stuff so that when you need to use it, it's available and it's ready for multiple teams and there's no bottleneck. So that's where a data lake comes in. You set up a pipeline where you can feed data into the cloud and land it there. And then from there, you can set up different spokes where that data can be federated downstream for processing for different use cases. So in the previous discussion, I did a real-time load of a database with about 15 million records across multiple tables, and it was a sports database, and put it in RDS, Postgres, and I did a live migration using our database migration service. Now, what this service did is it takes the data from the source and it sets up, source and replication endpoints, and a replication instance lives here. Think of it as a middleman, and it takes data from here and then it moves it into a landing zone. In our case, it was this S3 bucket right here, and S3 is our object store service. DMS, this service, database migration service, also supports ongoing CDC transactions. So it can be supported for like a live cutover. These databases can be up to date, and then you can manage a cutover at a point that you're comfortable. So we did that, and we had the data in S3 and a CSV and a flat file, and then we say, okay, now we have to understand, now that the data is in S3, what does that mean? So we walk through the ability to discover data, right? So this is data that we didn't know about. We don't know the contents of it, so we need to discover it, right? Because typically when you're persisting a lot of data into a data lake, it's going to be, you know, random, uncurated data. So you need to know what you have first. So what we did is we created a crawler. A crawler crawls the data in S3, and it identifies extensions that the files have, as well as the schema of the files to determine, you know, what is in this file. It's a lot of built-in classifiers that live inside of these crawlers that we build. So long story short, the crawler goes against this database and it produces a catalog of data. So now the crawler goes against these CSV files and it produces a metadata table, which is essentially a table that now has fields that it recognizes based on the contents of those files. So this is a logical table. Your data is still unstructured, but it's structured at the metadata level. So you can access it here natively as if it's actually structured data, right? So this is, again, the power of the data lake. The next thing is, well, we wanted to then take that data and turn it into a format that is more friendly for processing, right? It's more lightweight, compressed. So we use Parquet, very standard format. Some customers use Avro. You can also apply compression algorithms, you know, gzip, bzip compression based on the use case, and there's different reasons to use either one. Won't dive into the details for that. But that was the next step, is let's turn these CSVs into something that we can process, right? So we chose Parquet and we set up an ETL job in Glue, which will do the conversion from CSV to Parquet. So in that, we had to set up a ETL job, and now the data, the ETL job goes against the Glue catalog, and then it grabs this data, and then it runs lightweight transformations that are built in Glue. So Glue can do many transformations out of the box, right? So for example, Parquet is out of the box. You can just select Parquet in your ETL job, and it will generate ETL code that will be able to transform that data. So now we have this data in this bucket. And now we say, okay, let's discover this data so that we can use it downstream for services like Athena that can do lightweight querying, or QuickSight, which can look at tables or views from Athena and present a dashboard to an executive. So we did that. And now we're at the point where, you know, I want to focus a little bit more on the machine learning and AI side. So we're not going to talk too much about the data lake, just because I want to make sure that I give the AI piece some justice. We won't go too deep because it is a very loaded topic, but I do have a demo where I'm going to generate a forecast based on some data that I do have in S3, and I'm going to do it live. I also have one that's done already, because building these models in real time does take time. So for time's sake, if it gets to a point where in the process we're getting close in time, I can just flip to the version that's already completed, and you'll be able to at least see the output of the forecast itself. So with that context, let me pivot over to the lab that we're going to complete today. So just give me 1 second. Cool. Okay, so in this lab, like I said, we're going to use a service called Amazon Forecast, and let me just kind of give you a primer of kind of what it is and what it does. So Forecast is a managed service, and what I mean is a service that sits at the top of the machine learning stack, if you will. Let me see if I actually have that visual, which may allow it to resonate a little bit better. So when you think about machine learning in AWS, there's 3 layers that we categorize. The first layer is artificial intelligence, and the second layer is machine learning, and then there's deep learning. Okay. Oh, 1 second. Looks like I have the wrong display. What we're going to do is I'm going to swap the screen to share a new screen. There we go. All right, awesome. So we have 3 layers of the stack: artificial intelligence, machine learning, and deep learning. Artificial intelligence is for developers, folks like myself who aren't data profilers, aren't data scientists. We know a little bit, we learn on the fly, but we don't really know the SME level knowledge of deep learning, right? We want to consume it, we know how it can impact the business, and we know where it can be injected with APIs. Machine learning is more so where you have a lot more flexibility in the model pipeline and building out that pipeline. However, we have services like SageMaker that make it easy to host and manage that pipeline, right? So we'll give you the IDE, the Jupyter Notebook experience. We'll host your models on your behalf, but inside of that environment, you can configure and fine tune the model as you wish and bring your own models, use existing models that we provide, et cetera. And then deep learning is more for the data scientists of the world who set up their own frameworks from scratch. Maybe they have proprietary algorithms, proprietary frameworks that they'll deploy on custom servers with very specialized GPU specifications, and this is at the very bottom, right? So we're going to focus more on the AI side with the forecast. And let me just jump through some slides to sort of show you, where it fits in. So if you look at this, slide, we have the AI services broken up into many categories: vision, speech, text, search, chatbots, personalization, forecasting, fraud, development, and contact centers. So forecasting is going to sit right here in the forecasting. And as you can see, this layer is very fit for purpose, right? And this layer is built on the underlying machine learning technology that powers it, right? And a lot of these services were actually built on experience from Amazon.com. So for example, Fraud Detector is a fully managed fraud detection AI service where, in conjunction with data that we've trained on how to protect Amazon.com from frauds for the past number of years, we also allow customers to augment that with their own data to then have a specialized fraud detector algorithm ready to be used in production without the need to have the fraud detecting or fraud SME level knowledge from a machine learning standpoint, right? Fraud detection is a very specialized skill set. So it would require, a SME to really know how you would tune and train a model used for fraud. So we give these services to customers with those best practices and trainings up front, and we allow customers to leverage their own data to augment that model to make it more custom for their use case, right? And this is, again, how we're able to push this capability to the hands of developers. We're typically, when you think about this layer at the very bottom, this is definitely for more of the data scientist. And even on the machine learning side, certain developers may not be comfortable. I'm very comfortable with SageMaker. We're going to use it today. But again, AI services are the easiest and the easiest to inject as they are fully managed by AWS. So now let's just, I'm going to jump through quite a bit of slides. Give me 1 second. Just want to get to the forecast slide. Great. So Amazon Forecast, what is it? It's a fully managed forecasting service. And what it allows you to do is you can create data set groups that Forecast accepts, right? And I won't get into the details, but understand that Forecast has required fields, 3 required fields, and they have data set groups that contain those fields. So for example, for a very minimal forecast, it's time series based, right? So you need to have a timestamp field. You need to have an item ID field, which talks about the items that you're trying to forecast. And then you have to have a field to forecast, whether it's demand, revenue, or something, right? Those are the bare bone minimal fields required. And what Forecast does is once you build that data set where you have a time series data set and you're showing items, you're showing revenue, or some sort of series of data that you want to forecast for, you can hand that to Forecast, upload it into the Forecast console. You can use the APIs. You can use the Jupyter Notebook like I'm going to use. And then you can train what we call predictor. And a predictor is a model that is trained for a particular field. And once you have that predictor, now you can generate forecasts, right? So, I have my data. I create my predictor. I train my predictor. Now when it's trained, it's a model. I can use it for inference and generate forecasts in real time, right? So that's essentially how Forecast works. It's super quick and easy to use. So let me pivot the screen share back to this screen. 1 second. So I just want to show this last slide. So high level, here's the flow. So you have historical data, maybe sales, web traffic, inventory numbers, cash flow. You have related data. So this is a piece I missed. We also have the ability to add metadata. So you can add color to your data set. So your primary data set will be focused on whatever predictor you're looking to forecast for, right? Let's say it's close. So you have all of the sales for close items at a particular by a particular time series interval. So let's say every hour, your data set is going to have the amount of units sold for multiple clothing items. So you're going to have each item, it's going to have its own line item every hour saying, hey, here's how many items were purchased. Okay. Now your metadata data set can have data for each item around what type of item it was. Was it a promotional item? Was it on sale? Was it a small? Was it a large? Was it red? Was it blue? And then you can also have data about the weather. So at that time, right, when you were at the same time interval of your data set, what was the weather like, right? What was the weather going on at the time? Because that may be contextual. You may actually find out that when you add that color of weather to, you know, and forecasting sales with clothing, you may see some seasonal dependencies, right? So this is the reason that, again, we give customers that flexibility, because you can add as much color as you like as long as it meets the schema. It's in the you know, the time series format. Then you can add as much as you want, and we take care of the modeling, the training, and you can just fine tune configuration parameters or hyperparameters for your use case, right? So it really demystifies creating forecasts, which generally take a long time, at least in my experience. So with that being said, let's go pivot over to a new screen. Just give me 1 second. Great. So in this, quickly, I'm going to set up my environment. Awesome. So let me do this. Okay. Let me minimize this and bring up a different window with the correct. 1 second. Take this. Okay. So we're going to do that here. So let me bring this link to set up the lab. Just give me 1 second. How do I move this? Okay. Okay, 1 second. Trying to access something on the top of my screen and I'm having problems, but no worries. Okay, great. So now we have, hold on. Okay, great. So now we have, we're going to take this, wrong paste. There we go. Okay, so now let's get the Prelab stuff set up. And what this is going to do is it's going to set up a SageMaker instance, which I'm going to use to do my forecasting. So let me just run this template. Just VPC false, forecast demo, it's great. Just go in and just provision some resources. So this is going to provision my SageMaker notebook, which is where I'm going to do all of my forecast work. Let's give it about 5 minutes to complete. CloudFormation, for those who don't know, is the way to provision infrastructure with automation. So if you look here, this template is actually doing the provisioning of my infrastructure rather than going through the console. So it's a good way to programmatically have some automation in place to just increase the integrity of how you provision resources. So this will probably take around 3 minutes. So in the meantime, let me pivot over to different service. And let's get ready to get into this notebook. Let's go to SageMaker. And it should be creating a notebook instance as we speak. Yep, so as you can see here, here's the instance I'm going to use. As you can see, it's pending. It'll take about a couple minutes. So we'll just, we'll give it some time and some color, let it do its thing. Now I do have a question for everyone in the room while we wait. Maybe you can use the chat. I'm not able to see it, but I'm curious, does anyone have any use cases where you're looking to use, you know, machine learning or AI within your business applications today? I'm just curious to kind of understand the temperature for, you know, how you are leveraging AI, or is it something that you're looking to inject into your strategy? Or is this something that you haven't really had the time or the appetite to look into yet? Feel free to speak up while this is provisioning. No one. Okay.
Hey,
No worry.
this is Elvis. I haven't used any machine learning services. I've been to a couple of discussions about it, and I'm just curious to see how we can actually use it, particularly because the clients that I work for, they pay for a lot of vendor applications that do what I presume to be very similar things. So I'm just wondering if there's something that we could easily stand up that would essentially accomplish the same things and maybe save some costs.
Okay. Is there any, just to probe a little bit, is there any particular context as far as what you're looking to solve for, or is it pretty broad at this moment? You're just trying to see where you can fit in.
Fraud detection probably would be
Fraud
the
detection.
biggest.
Okay.
Yeah.
Okay, that's actually interesting. So yeah, I mean, we do have some materials on fraud detector as well. It's a relatively new service. I'd definitely be happy to send you over some, just provided I can't do that live today. But fraud detector is a very powerful service. We've seen a lot of success with customers using it. Let's see. Okay, still provisioning some infrastructure. Let's look at the event. So role was created. Looks like it's just finishing the instance. And this instance is what I'm going to use to run my notebook. So, T2 medium. So just let's give it some time. While we're waiting, let's take a look at fraud detector. Let's just have a little bit of ad hoc fun here. So let's take a look at the fraud detector console. Um, Define the event you want to access for fraud. Upload your historical event data set to Amazon S3. Great. Let's see. Okay, so I have to go in and okay. So I haven't personally used fraud detector. I'm very aware of how it works. Again, it's a relatively new service, but I will say that the main benefit that I've seen and the references that I've been aware of is, fraud detector combines data that you can provide around, transactions in your environment, and it already has a sort of pre-built model based on how AWS or Amazon protects against fraud, right? So this is a very good service from the standpoint of not needing that SME level knowledge, as well as data protection. So we do encrypt the data. The data is safe. The data that is used for these services, so there is no worry about data leakage or plain text data or us being able to manipulate any customer data. So that is also a security feature that we provide for customers as well. Fraud detection. Yeah, this will be a nice demo. Definitely, if interested, I'd be happy to flush out a demo with fraud detector, so we can get you some acceleration on that use case. So it looks like we're finished with the template. So let's go back to SageMaker. Let's pivot. All right, notebook instances, Jupyter Lab. Awesome. So we're going to go to notebooks. So this is a Jupyter Notebook. You can use Jupyter Notebook in many different ways, not through SageMaker, but this is an easy way, especially if you want us to host a model. Integration is a lot easier. So now we're going to open up our training notebook, and I'll walk you through what we're doing for the forecast. So first thing you want to do is you want to get access to our data. And the data we're going to be forecasting is a sample data set, and it is a utility data set. So it's individual household electric power consumption data set. So this is an actual data set that's publicly available. And you can do this on your own as well. So I can send you the links to perform this lab on your own time. And they aggregate the usage hourly. So this is where the time series piece comes in, right? So what we're going to do first is we're going to download some dependencies for the notebook. So some libraries, pandas, NumPy, matplotlib. Those are very popular packages to use whenever you're doing Python or working a Jupyter Notebook, mainly from a data prep standpoint. Pandas is very useful. Data frames. as well as visualization, right? So being able to do some plotting once you have the forecasts, those packages make that a lot easier. So now what we're going to do is we're going to read in the CSV file. So let's give it some time. Great. So we imported our CSV, and here's a snippet, just taking the first 3 records of the data we have. So we have the timestamp. As you can see, it's every hour. We have values for energy consumption, and then we have clients. So I've filtered this data set. This data set has multiple clients, like hundreds of clients. I'm just going to focus on one, just for simplicity, because it takes longer when you have more data. So I want to keep it small so I can make this as live as possible, even though I do have a finished one available if we run out of time. So we're going to describe the data. This is typically the first thing you do in any machine learning project. You want to describe the data. It gives you sort of points around how your data is structured, how it looks. You can see unique counts. You can see how many fields you have, the frequency of the most popular fields. And then there's also a describe all where you can see even more data. But for the sake of this, we'll keep it basic. But again, whenever you're approaching a machine learning problem, it's good to just kind of use the native libraries to let it describe as much data, to let it describe your data set, right? So that way you can see what data you have, and there's multiple different methods and different fields you can expose beyond this, right? But this is just, again, a demonstration, a quick demonstration. So you see we have timestamp, a value, and an item. The data set spans January to December for a whole year. So what we're going to do is we're going to separate the data. So we're going to have some data for training, and then we're going to have some data for validation. So let's just split the data. We'll do January to October, and then we'll just put everything else in its own data frame. And then we're going to export them to a CSV and place them in our data folder, right? So now, January to October has everything from January to October, and then this data frame has everything from October on to December. Okay. So the next thing is, once we split the data into CSVs, they're stored locally on our environment. So you see the current directory / data. So this actually lives within this directory. So I could actually go find it. Now what we want to do is put it into S3, our simple storage service, because this is a place where we can easily manipulate that data. So for now, I have to replace some names and some roles. So I have to give it the real bucket name that I have in my account. So let me go retrieve that from S3. I created a little bucket. Just go ahead to, I'm sorry, take this. Immersion Day Machine Learning, the role ARN. This is the role that was created for SageMaker and Forecast. So let me go retrieve that. And the role is, again, because everything is fine-grained access at AWS, every service that communicates with another service needs a role within applicable policy in order to carry out those tasks, right? So this is just sort of a thing you get used to in the platform, is knowing that you have roles attached to certain resources and they have certain policies, right? So this role can use identity access management, it can use Forecast, S3, and SageMaker admin level, right? So this is just the standard quick policy for the sake of the demo. So let's give this client that we're going to create, because we're going to create a client, right? So we want to make sure we give it access. So we do that, and here's the file name, and this is the Bodo3 package, is the package that we create to integrate with AWS services for Python. So we're going to create our session. Great, so that's done. So now let's get started with the forecast piece. In order to create the forecast, we have to do a couple of things. We got to create a dataset group for our for our data set. We have to create the target time series data set. This is what I mentioned earlier with, having the timestamp, the item ID, and the value. That's the standard schema, the bare minimum schema for forecasting. And quite frankly, it's required in general. I mean, you need to have those items in order to forecast anything, right? So then you're going to attach the data set to the group. You're going to import the data set, and then you're going to generate forecasts using these algorithms. Out of the box, we already provide them. You're going to query the forecast, and you're going to plot them. All right, so let's go ahead and start configuring some of the forecast parameters. So we're going to specify our format. For the timestamp is, year, month, date. The data set frequency is by hour. This is the project name. Here's the data set name. I'm going to call it project and then append _DS for data set. And then here's the data set group name, project _ data set group. So pretty standard stuff. And just for, for giggles, what's really going on is if I go to forecast now, you'll see that these resources are now available because I'm using that Bodo 3 package to create these resources, right? So this is what we just created, right? So we just created this. It has nothing yet, but it has the time series data, right? So cool. Let's do, hold on. Data sets. Okay. Okay, cool. So now, what we're going to do is we are going to continue to configure our client. So we have specified our region. Here we're creating the actual Bodo 3 session. So in US East 1, we're creating the client for forecast and the service name is forecast, right? So here's the forecast query, service, here's forecast. And these are just clients that we're going to be able to create to use throughout the demonstration. Resource already exists. Okay. 1 second. So I believe I know why this is happening. This may be the account that has the forecast, which is not a problem because we can easily do this. 1 second. We bring over a new tab. Okay. Yeah, this is the one. Okay. So what we're going to do is, let's do this. I'm going to swap the screen for a second. Great. Let's come over here and let's use this account. Let's swap accounts for a quick second. All right, let's go in here, see what we have in here. So this one is empty. Okay, so I can use this one. Okay, so let's actually, is this it? Target time series created 1027. Okay, so this is the right account, I believe. Interesting. Okay, so let's do this. Go to SageMaker. We're gonna pull up this this notebook. And let's open up Jupyter. Go to notebooks. Go to immersion day. We're just gonna pick up our notebook. Okay. Okay, so I'm gonna use this one. Looks like both of my accounts, I didn't delete the forecast that I already had, so it wouldn't let me duplicate. And for the sake of time, I do not want to go through deleting. So I have the outputs for the calls already saved in my previous forecast notebook as a failsafe, right? Just because, you know, sometimes things happen, right? So because I already have this created in both of my accounts, you know, we're going to walk through the notebook. So let's go back to where we were. So we configured our frequency. Make sure you can see the right screen. Okay. So we configure our frequency. You know, we configure the format. We create the metadata for the project. You know, we create our clients, and now we create our data set group. Okay. And here is the response, right? So that you get the 200 and you know your data set group is created. So now let me just take you to the console so that we can see it. Okay. And here's the data set group, right? So here's the data set group we created. And here's the target time series data set, right? And here's where you can add the metadata about the items, right? Or a related time series data set. But we're just going to focus on the primary data set for this purpose. So now the next step is go back to the notebook. Is now we're going to put the schema of the data set here, right? So I told you, you know, when you're using a time series data set, you have a defined minimal schema you have to have. Here's the schema. So we're saying, hey, here's the timestamp attribute, here's the target value, and here's the item ID, and here are their types. Okay, and this matches our previous data frame that we exposed prior, which showed those three fields. So we create our schema, and now we create the data set using that schema with the data set frequency, the data set name, etc. We get our 200 response, and now you know, we have the data set officially created. So then we go in, we do forecast.update data set group, and now we attach that data set to that group, right? So if you look in forecast, here's a data set group, and then within it you have data sets, right? You can have these three data sets. So what we basically said is we're going to put this inside of this data set group, right? We created this data set group here, and we're going to place this data set inside of it, right? If we added another data set, then we could have done the same thing. The metadata data set can go here, and related time series data can go there. Great. So now we call import the data set. And what this does is really intuitive. We're basically using the client to import the data from S3 into that data set. So we have the schema defined, but there's no data in it, right? We just determined the schema, we created it within forecast, but there's nothing in it. So what we do now is we create an import job. So we take the S3 bucket name and the file name, and we create an import job. So we give it a name, and then we do, you know, we call the forecast client again, right? We just create data set import job. We give it, you know, the basic parameters, the name of your job, the name of your data set group, the job name, data set ARN, and the data source, right, being S3, the timestamp format. And these are standard fields. When using the client, you'll see this in the documentation verbatim, you know, as far as the fields required. And then you create your data set import job, right? And now what happens is this was running because it's going to actively import that data into S3. So as you can see, mine's completed, and that is why you see this import job here, right? So it took data from here with this file and it imported it into this data set. So that's all this did. And it's telling me I have approximately 7,000 entries. So now that we have the data set in S3, it's time to do some modeling. So what we do is, you know, these are parameters that you can configure that are specific to the models. So these are the defaults: the forecast horizon, back test windows, you know, back test window offset, forecast frequency. We do have documentation that'll deeply explain what these mean. I don't want to confuse on this meeting, but you can accept the defaults. We're then going to create ARNs for the algorithms that we provide out of the box, right? So we can use them later. These are algorithms that we manage. So these are hard-coded AWS values, and we're just calling them because we're going to use them later when we're training a model using the algorithm, okay? So then we come and do the first one, Arima, and this is going to be the first model that we use for our predictor. And basically what we go in and say is, you know, we want to call this predictor project underscore Arima algorithm underscore 1. Okay, just a name. And then we're going to come here and we're going to create the predictor. So when you create a predictor, you use the forecast client yet again. You pass in the name, the algorithm ARN. So this is the resource name for the inbuilt algorithm that we provide. And you pass in your parameters, you know, your horizon parameters that we talked about. You can accept defaults for those. A lot of these you can accept the defaults for. And again, the documentation goes into extensive detail around each field. For the sake of this demonstration, not too relevant in understanding how to use the forecast service. That is more for if you have more of advanced asks, you want to change some parameters. But I would definitely recommend reading up on those to see if it's required before changing those. You then give your data set group ARN that is in forecast, your forecast frequency, which we already have above. And then here I've put in some featurization configuration parameters, for how I'm looking to train this model. Okay. And then I just run this. And now this Arima create predictor response is going to be the predictor that is going to be a result of this model. And we go through that process for 3 distinct models. One for profit, one for Arima, and then one for Deep AR Plus. And these are all very different machine learning models that have very different ways of modeling data. And what happens is once we run this, it'll take about an hour, or actually about 30 minutes to complete. So hence why I wanted to do it ahead of time. But it'll create predictors and they will be found here. So what these are is the finished product of you using that client, using that out-of-the-box algorithm to generate a predictor, which is indeed a trained model on your data, right? So now you have the ability to use these and produce forecasts, right? So here's the metadata about, my predictor, what model algorithm it used, any of the configurations that were used, the metrics for the predictor itself. Again, won't drown out the details of these parameters as it will become a very loaded conversation. But again, the speed to be able to use an out-of-the-box algorithm and generate a predictor is really the big win in this case, right? But just for context, I'll give some insight into Arima and Deep AR Plus and Profit, just so that you know when to use either one and what it's particularly good at. So Arima is good for data sets that can be mapped to stationary time series. So, the statistical properties of stationary time series, such as autocorrelations, are independent of time. So data sets with stationary time series usually contain a combination of signal and noise, and this signal may exhibit a pattern of oscillation or have some seasonal component. So Arima acts as a filter to separate the signal from the noise and extrapolates the signal in the future to make predictions. So again, a lot of this is going to come from just testing and learning to really see when it matters to use either one. But that is typically the use case for Arima. It helps you, move the noise away from the signals that should trigger you to make a particular decision, right? And that's what it optimizes from a machine learning standpoint. The profit algorithm is very useful for data sets that have an extended time period, so months or years, with very detailed historical observations. They have multiple strong seasonalities. They include previously known important but irregular events. They may have large outliers and have non-linear growth that tends to approach a limit, right? So that is particularly a use case that is very common to use a profit algorithm for. And again, a lot of this you're going to see better in action than remembering conceptually, especially if you're not a data scientist. But just some quick context. And then the Deep AR Plus is actually a supervised learning algorithm for forecasting scalar time series using recurrent neural networks, right? So this is a, it uses neural networks under the hood to be able to do supervised learning. And it takes a little longer for this one to run than the other two, for obvious reasons, right? Using neural networks tends to be very intensive from a time standpoint. So provided, these predictors were created, my create process went on for some time. So this interval went off every 30 seconds. So this took, maybe about a half hour. And then the model was complete, right? So now what you can do is you can evaluate the metrics of your predictor. And this is where you sort of get into the machine learning bits of the equation. So as you can see here, I have the ARN for my predictor, and I'm going to use the client, the forecast client, to get accuracy metrics. So this is a built-in method within the client itself. So typically when you're doing machine learning, a lot of people will create the accuracy matrix, the accuracy matrix. Some folks call it that, but really it's the matrix to determine, how is the accuracy of your model, based on the validation data set. So that's what this Arima metrics parameter is returning, and it's printing. So if you look here, we have a number of fields. But we calculate, loss value and a number of different metrics to be able to give you a threshold on, what we feel like your model, how we feel your model is performing from an accuracy standpoint, right? And this is where, as a data scientist, you can go in and look at your loss value and see, okay, maybe I need to fine tune some hyperparameters and retrain the model, right? But this is where you can at least get the output and start determining, like, okay, you look at your metrics and determine, what is the next steps as it relates to fine-tuning hyperparameters or configuration variables and retraining the model again to get your output at a place where you feel comfortable from an accuracy standpoint, right? And the same happens for each model. So they have the same method, and they're doing the same thing. They're getting the accuracy metrics. So just let me pull up 1 second. Going to pull up a quick blurb. Great. So again, when using the get accuracy metrics, it computes a number of different items, right? So it gives you this quantile 0.9, 0.5, and 0.1. And basically what they mean is, for example, for the 0.1 quantile, what this means is for the prediction, the true value is expected to be lower than the predicted value 10% of the time, right? So for example, if you're a retailer and you want to forecast product demand for winter gloves that we sell only during the fall and the winter, if you don't have a lot of storage space and the cost of invested capital is high, then you might use the P10 quantile in order to order a relatively low number of winter gloves. You know that the P10 forecast overestimates the demand, and only the P10 forecast overestimates the demand for your gloves only 10% of the time. So 90% of the time, you'll be sold out of your winter gloves. So that's what these quantiles mean, right? So this one is an overestimation, right? This is overestimating, which means that, 10% of the time we're going to overestimate, but 90% of the time you're going to be under this number. And the same applies to the 0.5 and the 0.90. For the P90 or the 0.9, the true value is expected to be lower than the predicted value 90% of the time, right? So if you determine that being understocked on gloves will result in large, loss of revenue, then the cost of not selling gloves is extremely high. So you might choose the P90. You might focus more on this, right? On this forecast, because this will allow you to be overstocked more so than understocked. And this is more of the median. And we'll visualize this in a second so you can see the predictions that use each one, because each of these generate their own prediction based on how they look at that model, right? How they evaluate that model. So that's what the output is really getting at is, you know, this helps you determine if you want to overestimate, if you want to be sort of in that middle ground, or if you want to underestimate. Right? And you do that for all three of your models. And this is, again, how you would quantify, you know, accuracy, and how you would, you know, determine if you wanted to go through a second iteration of training. So now what you do is you have the forecasts, you have the models created. So you want to generate your forecasts. So you create a forecast name and you use the client to create a forecast. You pass in the name and you pass in your predictor. Right? All things that we have gathered from previous steps. And then you find the ARN of the forecast itself, so that way we can retrieve it later. And the same process happens for all the models. Okay? And this step again was already ran. So if you look here, we have 3 forecasts created, right? Today or Thursday, so this was yesterday. I have one with each algorithm, right? Now you don't see what the forecast is saying because it's not available yet. It's not local. I've generated it, but I haven't pulled it into my environment. So now we're going to export the forecast to S3 because they already live in S3. I mean, because they don't live in S3 yet. So resource already exists. That's fine. So again, this is because I tried to run it twice. So no issues there. But what you're going to do now is you're going to take the path of each file, right? So you have your S3 bucket, you have your the path for your forecast that's in S3 that you just generated, right? And now you're going to create a job to export that into forecast for each algorithm, okay? And that is what you'll see here, this export. So just like we imported data into the data set, you export your forecast from S3 into forecast, right? So it's coming from here, right? And now it's a part of this export job I just created, right? And we do that for every job. So now what we say is, great, we have the forecast, so now it's time to look at them. So this step here does some prep with downloading the forecasts and putting them on my notebook, right? So we're just gonna, store them. We're gonna download them. We're gonna put them in the, local directory under the data. And you'll see the output of those files here, right? These CSV files here are the files that I am exporting into SageMaker, right? So then now I can visualize them here. And now what we can do is, we have the file names, and now we can actually look at the forecasts, right? So here's an example of what I mean when I say P10, P50, and P90. So let's look at this first model, for example. This Arima model, I'm visualizing a forecast from the Arima model. Okay, and what you can see here is you see 3 levels. You see P10 is in blue, P50 is in orange, and P90 is in green. And this is, again, what I stated is the P10 algorithm, it underestimates purposefully, right? You get 3 thresholds. So it underestimates so that 90% of the time you're going to be under, but 10% you're going to be over. So this is good, again, for if the cost of understocking something or under having something is not high. It's like, maybe I need something that's seasonal. I don't want to overstock it, but I need enough just so that I can keep the business moving. So this would be applicable to use. The P50 is more in the middle. It kind of the median of both. And then the P90 is the more aggressive one. So this is where it'll take into account multiple different factors to make sure that 90% of the time you're over your threshold, and 10% of the time you may fall short, right? So this is typically, again, useful if the cost of not having supply or not having something, or the cost of being under the number is too expensive, meaning you can't afford to under forecast. You have to at most be over. Then that would be a better algorithm to use within your application. So as you can see here, right, we're going to predict based on we're going to use the model to do a simple prediction, right? And we're going to let the model tell us what they think that the output or the consumption will be for this particular client based on forecasted data, right? So what this is saying is the P10 is saying that I think this person will consume 80 units of power this month, right? Which means that I'm underestimating. This means that this person is probably going to be over. So this may not be the best one to use if you're an energy company, because you don't want to underestimate the usage across a fleet of individuals, right? So you may look at the P50 and say, well, this is a median, right? Maybe you'll look at your data and you'll understand the volatility of it and determine that, maybe this median is more appropriate. Or if you know that maybe it's a lot of activity going on, maybe it's disasters, or maybe you just notice your data set is very volatile, then you may want to go with the over prediction to ensure that you can meet the need for a particular region, right? Let's just say that it's crucial that this region has a stable amount of energy, right? And it's mission critical. Then again, you may go for the overestimated model output, right? And again, this is just visualizing that same forecast over a series of time, right? So we're just, giving it a time range and, allowing it to, forecast over that time using each model. What does each model think the consumption will be based on its particular configuration, right? And here we can see our prediction goes from October 31st to November 2nd, right, as expected, given our 72-hour interval forecast horizon, right? So our forecast horizon that we gave was 72 earlier, which is why we're predicting over a 72-hour time frame. And we can also see the cyclical nature of the predictions over the entire time frame, right? So now we're going to create a data frame of the predicted values from this forecast and the actual values. So, here's us predicting the P10, the P50, the P90, right? We're going to plot that. And now what we're going to do is let's come down to the actuals. Scroll down. Let's just scroll down here to skip all the plotting. And here you see the actuals, right? So this model, you can say, not really the best, right? It was okay, right? It looks like it kind of had as you can see, this underestimated quite a bit, right? The actual is the red. And for the most part, as you can see, this is under the red until about here and here, right? So as you can see, the P10 is going to underestimate. Whereas you see in the green, the overestimation, the P90, this ensures that you're pretty covered, right? There's a lot of gap though, right? You see this gap, right? There's a lot of gap. However, you can see that how it over predicted. And then the orange is the median, which was probably the closest between that and the P10, right? So, this is kind of how you can see how your model performs over some actual data, and you can determine, right? From here, how do I want to fine tune it? Do I want to change the horizon I forecast over to be bigger or smaller? Do I want to change hyperparameters of how I'm managing the iterations of how forecast is modeling my data behind the scenes? That is when you get into the configurations of that of the model creation during the create predictor API call that I showed earlier. And that is where you can dive deep and start to really just test it and experiment and see the impacts that those changes have on the output versus your actuals, right? Now, it always depends on the use case as well, because you're going based off historical data, and it really is always contextual. There may be some sort of impending disaster or some event that may make the historical data not as relevant. So you have to kind of play it. You have to kind of use some context as well to see what is the best approach for over what interval do I want to forecast? How often do I want to generate these predictors to keep my forecasts as fresh as possible based on as much data as I can give it? And in conjunction with that, and being able to calculate, your accuracy metrics for each model makes this process a lot easier. Right. So once you're able to create this pipeline in a notebook, you can spin this out and create as many models as you want. We have more than 3 out-of-the-box models. We have about, I think, 6. And you can create as many versions of a predictor as you like. So you may say, okay, I don't like this predictor. I want to make a new one. And I'll add some data to it. I'll add some color. I'll add, some metadata. And then I'll rerun the model, right? That will make this model more have a higher integrity. Remember, this data set does not contain any sort of supplemental data. So this model has absolutely no context to anything except numbers and client IDs, right? We didn't add anything about the seasons, about the temperatures, anything that may impact usage, right? That is relevant for a forecast, right? Meaning it might be cold, might be hot, might be hurricane season. Who knows? Maybe it's summertime, everybody's moving in, partying, so usage goes up, or maybe because it's the pandemic, no one's partying, or they shouldn't be partying, so it may go down, right? So that's where the metadata comes into play, and adding that color makes these forecasts a lot more relevant, right? So again, remember, right now it looks kind of bad, but it's okay because we didn't add any color. We just wanted to spin it up quickly and just get a forecast and just see how the process worked. And you can see this process for each model. So the profit model, a little bit different. So this one has some interesting, dips similar to the other one, where the latter half of the forecast kind of had a big gap in between, the expected. It looked like this one kind of went under as well. So it's pretty similar to the other one. And if you look at this one looks the most different. This is probably this is the most different algorithm of the two because it uses the neural networks behind the scenes. So as you can see, this had an entirely different outlook from how the lines kind of blend together. It looks like, this model is not too bad when you look at the P50, the median, right? That red line sort of rides that yellow line pretty closely for majority of the time, right? You're kind of safe when you look at that P50. I mean, the P50 for this model was very, very close with minimal color, right? We didn't add any flavor to this data set, and yet we're still able to predict a pretty interesting trend, right? Now, again, you want to make sure you don't overfit your data, and you got to run through best practices, right? But again, the ability to spin out these models is really the benefit, and generating these forecasts, whether you do them, no matter how often you do them, is a great value add for businesses, whether it's inventory based. When you think about, even Amazon.com, how they're able to keep certain products, always two-day delivery. The distribution centers always have certain products that are just ready to ship, and even sometimes same day. Right, that is all powered by Amazon Forecast. Forecast was predicated on best practices learned from Amazon, and they heavily use these services on the retail side to enhance the way that we service our customers. Right, and at that point, this is honestly the gist of like a 101 discussion of forecast. Hopefully, I didn't confuse anyone with this Jupyter experience. It may take time to get used to, but essentially it's just a notebook that holds code, and you create these cells because it gives you reusability. So I can make a section that trains my model, and if I do my evaluation and let's say I don't like it, I can just pop back up to a different cell and rerun that one cell to do my model training, or a group of cells to do my model training, and then come right back here. So it helps you group together processes that you want to run. And it really is a very efficient tool for anyone doing any sort of data profiling. So with that, I know I've talked a bunch. I just want to ask, are there any questions? I know there may be questions. I want to give you all time to ask any questions. After seeing the workflow with Forecast, is there anything that, you'd like me to touch on, or anything you just like to, have an open discussion about how you can inject this, or just any questions in general?
Yeah, just come off mute or put something in the chat for Corey.
Hey Corey, this is Johnny Newman. I'll ask a general question, more of like how it's applied. But after Amazon acquired Whole Foods, my wife noticed that there were some products that normally might have been on the shelf that were empty. I was just curious if this technology was used in the Whole Foods solution, and if the forecasting might be used in those type of cases.
That's a good question. To be quite honest, I'm not too well aware of, the Whole Foods side of the house, so I'm not too sure about their usage of Forecast. I don't want to make a statement that is not 100% accurate. However, it is used again in multiple pockets of at least Amazon, and the way that we manage our distribution centers, for sure. That is a big flagship of how Forecast has vetted its validity to the market.
Cool. Thank you.
And also a quick side note, similar process for a service called Personalize as well that generates recommendations. That service is used extensively in the Amazon.com app. So when you look at the left bar and you see similar items, or you click a certain item and suddenly you see people have also viewed this, that technology is also powered by Amazon Personalize, right? And these products were both born based off those best practices. So just kind of wanted to throw that out there as well, as, the similar workflow for how you would test and train a prediction, a personalization algorithm. And the workflow is pretty similar, as well as the usage in the real world is very, very heavy to core business on the Amazon side. So I have another question. Does anyone have, is anyone looking to leverage, any sort of forecasting for, let's say their ERP systems? Typically my customers who, have ERP systems are looking to, create solutions where, they can forecast inventory, forecast revenue, and sort of just make better use of their data. Is that use case relevant for anyone in this call? No? Okay. Okay, no worries. Again, any questions, feel free to reach out to me. I'd be happy to dive deep into, giving some more color to any sort of services. And even on the fraud detection use case, I'd love to come in and maybe, flush out some ways you can use that, if that sounds like something that would be of interest to the crowd. Or even just ideas on things that you're working on. I'd love to hear some feedback on just where everyone is today, and how I can, provide some assistance, if anyone's willing to share. Looks like we have a quiet crowd. I must have scared him away. Sorry about that, Justin.
Oh, no. You did great. Anybody from the crowd? No worries.
Actually, I do have a quick question.
Yes, sir.
So currently, my company is using more Azure machine learning.
Okay.
And one of the biggest gripes I have about it is this 10 gigabyte limit that they force us on. Is there like a similar Achilles heel to this Jupyter Notebook? Do you know like what the gigabyte limit? Because if you bring in 10 gigabytes of data and you're trying to train a neural network, it's gonna break it.
No, absolutely. So I have a couple of things. We do. I'll check on the hard limit. However, we do have a way where we compensate for allowing customers to load large amounts of data into Jupyter. So, two things. We have integration with a native Windows file system that can be attached to a Jupyter Notebook. So it would similarly act like attached storage. You would interact with it just as you would local storage. And the Windows file system service that we have, Windows FX, is highly performant. So from a performance standpoint, you won't see much drop off. The other option is, we can use data directly from S3. So because S3 integrates with Jupyter, if you don't want to use a file system, and maybe you have more of a tolerance for data latency, you can use S3. Typically, the file system integration is obviously a little bit faster, more performant. S3 is also a great landing zone because you have, access to literally infinite amount of data storage. So you can just, point SageMaker to whatever data you're trying to load. And it just may take a little bit longer, but it'll still give you access to, essentially launch as much data as you like. Now I can still look into the limit for the Jupyter Notebook. I'm looking into that right now. You said your current limit was 10 gigs?
Yeah, it's 10 gigs, but it's like the actual memory to spin it up. It's like if there's that much memory being used currently. So one thing you said about the S3, I would think that maybe you guys have some sort of written in thing to load partial chunks of the data.
Yeah.
So you could train on a 100 gigabyte file, but if it's only loading in 10 gigs at a time and sort of cycling through, it would still work in Azure if you set it up that way, but...
So you're basically just looking for a beefier instance, essentially, so you can have more data to load.
Azure ties you to 10 gigs no matter what.
No, absolutely. So SageMaker, let me actually just look. Let's try to set one up.
I'm sure this was something I could probably find.
No, that's totally fine. Let's go ahead and check it out. So I haven't tried to test the limits on this thing. So I think it's...
Hey, Michael Dykes, you're one of the winners for Uber Eats. If you want to shoot me your email privately in the chat.
Okay, great. Yeah, thank you.
So it looks like, let's see, C4 8XL, M4 16XL. Let's see how.
Okay, so it looks like you almost get an instance of a compute, an instance that you can choose the size of yourself.
Oh, absolutely. So let me backtrack.
Yeah. And
just to add some color, the memory in this one is about 256 gigs.
Okay. Yeah.
So I'm sorry. When you're doing SageMaker, you can provision the type of instance you require. So you can use the M family with the T2 family, standard family. You can use compute optimized. So this will have more of a ratio on the compute side. And then you can use the accelerated compute in the P family. The P family is, these are pretty beefy instances. I believe they have GPUs. Let me check.
I bet you a set of those has GPUs.
Yeah, I think the P family has the GPUs. Let me see with the 16x large.
Yeah, there's 700 different configurations. One of them.
So this is the ideal for GPU based. So this would be sort of your best friend in this scenario. The P family would give you a pretty beefy. It's probably the biggest ones we have. So yeah, you'd have upwards of looks like they have 16XL. It's 488 gigabits of memory. So
that's ridiculous.
Yeah. So you have a good amount of space in here. And again, if you wanted to do it on your own, I mean, you could host this in EC2 and provision an instance with terabytes of space if you had to. But from a SageMaker standpoint, we'll host it, for any of these sizes. So, bring as much data as you want, man.
Cool. Thank you.
No problem.
We've got about 8 more minutes. Anything else from anybody on the call? No worries. Corey, that was awesome. Thanks so much. Really appreciate everybody jumping on and being able to join with us. Remember, there's links in the chat for the YouTube channel and our website. So check those out. I'll put those back in.
I have one question.
Yeah, go ahead.
Who was the individual who mentioned the, I didn't have my screen up to see the name. Someone mentioned the fraud detection use case. I'm just curious to know who that was.
Oh, that was Elvis.
Elvis? Okay.
Yeah, he works at Everest. I can put you in contact with him.
Nice. Okay. Yeah, I just wanted to kind of see if he wanted to see something specific. I'd love to follow up with him, even if it's separately, just to understand how we could get something in front of him.
I'll connect y'all on the email after the call.
Nice. Thank you.
Well, if that's it, we'll go ahead and wrap it up a few minutes early unless anybody has anything else for us. Awesome. Appreciate everybody coming on, staying the whole time. Hope you found this valuable, and look to see folks next month or the month after, whatever makes sense for you. Really appreciate it, everyone. Have a great day.
You too.
Yes, sir.